probably bi-weekly. We're going to consider that moving forward. But Beth and I organized this lunch and learn, and so we have a great speaker today, Dr. Nima, and Shay, and Dr. Shay, and I'll let Professor Victoria introduce him for a little bit, and then we can
Okay. Hi everyone, thank you for showing up, seeing common faces. So Dr. Nima, I met him, you met him through LinkedIn, and I've seen the great work he's doing here at Miami. And he's in charge of the Miami AI Club. So instead of having the Wilson AI Club, you can also join the Miami AI Club, get to see what they're doing out there for Miami. And his main goal is to bring awareness here at Miami, make more companies aware of what AI is all about. So that's why I thought to bring him today to come and share the same concept for us as MBC and see what can we also do. What is a trending topic out there in Miami that we can do for MBC as well. So let him take over, and take,
if you want to
lead us according to
give us a little bit about your background.
Okay, yeah, absolutely.
And as you know, we do have food coming for the second half of our lunch and learn.
Hello everyone, I'm Nima, nice to meet you. Who here is passionate about AI? Yeah, nice. So I'm in the right room, that's good. My name is Nima Shay. By background, I studied medicine, neuroscience like Michael. I'm passionate about how our brain works and then use that in order to create better machines, better AI. But before going to that, I want to share my story, that how I landed here, and also what's important for me, what makes me in the mornings, and what makes me passionate about AI. So, who here can define what's responsibility? What's the definition of responsibility?
Responsibility?
Yes.
No.
That's not related to AI, but in general.
Obligation.
Taking care of something.
Okay. Anything else?
Ability to respond.
Okay.
The readiness to take consequences.
Okay. Anything else?
Obligation.
That's good. And all of these answers are correct. Just thinking about, we have like different definitions for responsibility, but at the end it's kind of like we have some intuitions about what is responsibility, but not saying it in words. But my journey, and I'm going to return that towards responsibility and AI, started around 20 years ago when I was in medical school, that I was passionate about creating better machines, and I was skipping classes from medical school, going to computer science classes. Back then AI wasn't a thing, so that was like control engineering and electrical engineering classes. And what I learned was that all the engineers in the room, they didn't have any knowledge of the biology. And in my medical school, the biologists, the medical students, they didn't have any knowledge of electrical engineering or AI in this case. So there was a gap between both sides, the engineer mindset and also the biological mindset. So as I went to the medical school and I learned more about how our brain works, we started collaborating with the engineers, and we had a simple hypothesis, and that was emotions are good. Back then, everybody was saying that emotions are bad, don't make any decisions based on emotions, and nowadays it's still, that continues. Like people say that depend on your logic, don't listen to your intuitions, don't listen to your emotions. But the fact is that if emotions are bad, why are we emotional animals? During the evolution, like tens of thousands of years, we should have lost that, and because biology is very efficient, right? So the fact that we are still making decisions based on emotions shows that there is a potential, there is a benefit to that. And so we decided to bring that to machines, to make better machines. But the problem was that how can we define our emotions? Like we can name probably like 6, 7, 8 of our emotions, but the rest of the emotions are unknown even to us. Like if I tell you to define what's the color of green, it's very hard to bring that to the words, right? How can you define green? Or if you want to define your emotions, it's going to be the same thing. It's very hard to bring that to the words. So in order to bring emotions to AI, we had a different approach. We studied how our brain is processing emotions, and then we brought that to machines. Basically, in our brain, we have different areas. Some of them are responsible for some functions, like you have thalamus, you have orbitofrontal cortex, you have all these different components of the brain, which is very complex, but some of that is known to humans. Some of that is not still known to humans. So the part that is known, those neural pathways, we studied them and saw that, for example, this area is responsible for this function. This area is responsible for another function. How some of these areas are exciting some of the other areas. Some areas are inhibiting other areas. And we created that model. And that was in a controller. Controller means like, for example, you have it in this room to control the temperature. If it's too hot, it makes it cold. If it's too cold, it makes it hot. So that's like a function that the controller does. And we brought that into the first generations of controllers that they had emotions. So they didn't function like, okay, I'm sad and I'm gonna make the room cold. It had the components, or it mimicked the way that we, the humans, we are processing the emotions. And we proved that these controllers make better decisions. They make decisions faster, because if you see a lion, you just run away. You don't think about, okay, what are my options? You just run away, right? The fear would take over. So emotional response is faster. And it needs less computation power, which is important for the AI world. As you are seeing more and more AI is happening in the world, there are also, you should think about what's the computation that is associated with those algorithms. So, better decisions, making decisions faster, and relying on less computation power. So they are superior controllers. So in fact, it showed that emotions are better for decision making. And since then, this is like 2002, it's been used in a lot of industrial use cases. Your washing machine probably is using that. A lot of drones are using that. It's being used because it's faster. It's used in like high frequency trading, meaning that when you want to make decisions fast for selling or buying stocks, and any area that you don't have access to the cloud or a lot of computation resources. So this was my journey until for the last basically 22 years now, that we helped to shape and bring this type of engineering mindsets into the reality, into the industrial use cases. So now it's being used in 400 industrial use cases, like nuclear facilities are also using that because they don't have access to cloud. Last year, I realized that this technology is now being used in missile control systems. So imagine that the technology from 20 years ago now is being used after this amount of time in missile control systems, which I'm not excited about. But we made the application open source for the benefit of public and for the good of the society. But the fact that it's being used for this purpose, it was an aha moment for me. So I realized that the technology from 20 years ago, back then it was super naive compared to what we are building today. Now it's being used for such purpose. Imagine that the powerful technologies that we are creating today, how would it impact society 20 years from now? And that's not a beautiful picture, because we are just thinking about building things, like making technology more advanced, but we don't think about what are the consequences of those things that we are building. And I'm going to go through some examples of that, but just think about, let's say, for example, ChatGPT, like social media even. Like social media was a tool from 2007, Facebook, MySpace before that came, and it was a tool that we all enjoyed, and every one of us is on social media connected through LinkedIn. But at the same time, it had a lot of impacts on, let's say, the students and the kids and the next generation, and it's going to be more and more. So when they built the social media, they didn't think about the consequences that it has on the society 20 years later, right? But the AI is a very powerful tool. It's not like social media. So social media is a powerful tool. You can influence societies, you can influence people, but it has some limitations. The limitations of AI is potentially endless, because we are creating something that is more intelligent, and its intelligence is increasing every day. There is a law called Moore's law, which basically means that you can basically exponentially increase the speed and the potential of AI, its intelligence, and there's no limit to that. Who here has watched a movie called AlphaGo? What do you think about it? Just one in the back. Thinking a little bit of background, what was the movie about for the people that haven't watched it?
Alpha, what's the name?
AlphaGo.
Huh?
AlphaGo.
Okay, what?
It's on YouTube.
Okay.
The whole thing's on YouTube?
It's
The whole thing?
yes.
Real,
yes.
is he ready?
And it's free.
The game, League Sofa?
Yes, yes.
That's what it is?
Michael, you want to?
Yeah, well, yeah, so I would say it's that they designed based on reinforcement learning to defeat after chess Go, which is much more complicated than chess, and it won, and so it's may show some intuition and creativity and those kind of human elements of cognition that you need to like win a complex game like that.
Absolutely, that's true. So we know that the game of chess a few years ago, Watson was able to beat all the humans in the world. So the humans were like here, and then chess of the AI is like here. We can never, as humans, beat AI in chess. And then it came Go. Go is a more complicated game. It's more popular in East, and it's very more complicated because it has probability, it has chance, and it's very hard for computers to model that. So what they did, the team of DeepMind, which is a company that later on was acquired by Google, was that they had reinforcement learning. Basically, reinforcement learning means that you learn from your mistakes. When you do a bad thing, you get a penalty. When you do a good thing, you get a reward. And so in each iteration, you can analyze your response, see if it's right or not, and then if it's good, you give reward. If it's bad, you give penalty, and the system gets better and better. But there is no limitation to that getting better and better. Like we as humans, we have some limitation because let's say we can play the game of Go, let's say 5 times a day or 10 times a day. But the machine can do that 1,000,000 times a day, right? There's no limitations to that. And can do it for 1,000,000 years, like unlimited amount of time. So it can become virtually better and better. So the movie shows that at the beginning, they trained it with like a very good Go player. At the beginning, the gentleman was able to beat the game very easily. And it became harder and harder for him to beat the AI. And they came to a level that they were equal, and then the AI surpassed. Then they played with like the third person in the ranking of the board, and then the same. Like at the beginning, he was able to beat AI, and then they became equal, and then AI beat him. And then the first person in the world was a Korean gentleman. He was like the best in the world with a lot of distance with the second person in the world. And so at the beginning, they have like a 7 game tournament. So at the beginning, he was very easy, able to beat the AI, and then it became better and better. And then on the 4th and 5th and 6th, AI was able to get better and better and easily beat the human in just a very simple way. So even the human wasn't able to compete with that AI. It was in a level that people that were watching it, they were all that, okay, why did it make this move? It's not the right move. They were all surprised.
Yeah, they're saying how it's working as a non-human move that no human would ever use.
Yeah.
Exactly. And so that was the creativity. So AI, we can define it that was creative in creating a solution to beat the human, because the purpose of the AI in that case was to win the game. So it was optimized to win the game, and it won the game. So never ever that the first person in the world were able after that to beat the AI in a few years afterward. In fact, it had become so complicated that now it's the game of AI versus AI, because humans cannot participate. We are not intelligent enough in order to be able to play with the AI.
Question. Do you think if they remade that film now, you would have a different result? Because I looked it up and it says it was made 4 years ago. You know?
2016 or so, I guess it was.
It just says 4 years ago. It's on YouTube, so it says 4 years ago.
Yes, that's the one, yes.
But with the advancements that have happened 4 years ago to now, if they remade this now, would it have a different result?
I'm going to tell you. So if you go to Wikipedia and see what happens after that, it reached to a stage that it became 100 times more intelligent than humans. And then 1,000 times more intelligent than humans. And then they saw that, okay, we are not ever going to treat this, so what's the purpose of that? And they pulled the plug. So we created something way more intelligent than us in that area, and we literally are not able to ever be able to compete with them. And this is the power of reinforcement learning, because you are making it better and better. Now coming back to the world of AI, we are all excited about AI. I'm very excited, I'm sure you are all very excited. But at the same time, you have to think about if we don't fall into that AlphaGo trap, because if we are creating something that is super intelligent, way more intelligent than us, which is called AGI, Artificial General Intelligence, or ASI, Artificial Superintelligence, there are different names, but we virtually are creating, or some people are creating an AI that is way more intelligent than other humans, and it can reach to bypass the human IQ in a couple of years, or maybe it's already, we are at that stage, and then in a few years, it's going to be an AI that has IQ of 500 or 5,000. What does that mean to us? What happens to us, the humans, when we are not the most intelligent being on the planet as we perceive and we think that we are? So what would be the world after that? Is it good or is it not good? Let's raise the hand. So who thinks that it's good to have like a smart team with the IQ of 10,000? Raise your hands.
I mean,
Can I vote for both?
I was about to say, you can be both.
Both.
You can be.
You can both?
Yeah.
Yeah, okay. And who thinks that it's not a good idea? Okay, exactly. It's correct. That's technology, right? Any technology is a tool, right? It can be used in a good way, and it's going to be a very good tool, and then it can be used in the bad way, and it can be a very bad tool.
but it's a tool of evolution. You're calling it a tool, it's kind of evolution.
Evolution that we are having control over that, right?
But we're gonna lose control, so we can already know that. Eventually it's gonna be smarter than us, faster than us, so it's
Not
gonna
if-
evolve out of us.
Not if we have enough control over it.
Yeah.
Yeah.
I would challenge the idea that we have control over it. I think that, to Maddie's point, it's an evolution of ideas that are evolving, and that there's a lot of people working it across the world, and the way it's already like evolving by itself in the sense that we can't control it. So even if Congress tomorrow passed a law and says no more AI because this is dangerous, it's going to destroy the United States, so the United States Congress says no more of this, there's no stopping it. It's going to keep on, other people are going to keep on evolving. So I think there is no one person that can control it, and even like unless every single human being on the planet was on the same page and tried to stop it, then there's no way to stop it.
That's a valid point.
No,
Yes.
that's what I'm saying.
So just we are talking about AGI and not AI, because I mean there are technically some overlaps, but in the terminology that we are using here, let's focus on the differences. We talk about that sentient being that can make decisions by itself, have its full control or own control, AGI, and then AI as a tool that we are creating today. So I agree with you. It's very hard to be able to control. And at some point, it's going to be more powerful than us. It's going to be wealthier than us, because it virtually can have like enormous amount of wealth. If it can predict the stock prices better than any human, if it can predict the weather patterns better than any human, it can predict the coffee prices, the bean prices, it can do trading, it can become super wealthy. It can become super powerful. And all of that goes back to the one simple question that we are still trying to figure out. And that question is, should AI have any legal rights or not? And this is a big dilemma. If we start the conversation, I'm sure it's going to take a couple of hours, but let's give you two scenarios. Scenario one, we say yes, let's give AI legal rights. So we are addressing it, we are recognizing it as a being that has developments. So that means that it can become like a company. It can have a bank account. It can do transactions. It can do trading of stocks. So eventually, that company will surpass Apple and every other company because it's just like one person or one being, and then it can do all of that and become wealthy. And it's not going to die. We are dying, but that one will continue. So for sure, like 500 years from now, if we survive that, it's going to be the most powerful entity in the world, and we are all going to work for that. So that would probably be somehow a very scary scenario because it can have intelligence in a lot of aspects, but it cannot have intelligence in some aspects. Maybe it doesn't have the emotions like us, or it's not sentient as us. So what happens is that that being wouldn't have the same empathy that we have, the same concerns that we have to other humans or other animals or the nature. Why? Because it's just created by us, and we haven't been the best example for taking care of the universe and the planet.
Well, you're also saying that we can't upload our consciousness, actually.
Not the same consciousness that we have.
You're making speculation that we don't know if we can in the future, right?
So consciousness is a very gray area, and Michael can also elaborate on that. So our dog is conscious. The cats are conscious. The animals are conscious. They have consciousness, right? But the way that they have consciousness is different than us, because their sensation is different. Like they have like different sensory inputs than us, right? So the sensation is different. The perception is different because we have like visual perception, they have visual perception, but the way that they see is different than us.
So if I die, I can upload my consciousness and I have my same guardrails, my same parameters in that aspect, right? And we're saying that today we're building our technology in emulation of us. And we're going to continue doing so. We're hardware now, and then we're going to go into bio tools, bio memory. So maybe we might have that. We don't know. We can't predict the future, right? We can all make sci-fi movies.
Yeah. We have a limited understanding. You want to?
Oh yeah, well, yeah, so, I mean, like that, no, I would say that that's also an assumption. I'm not sure if consciousness is required for sentience or intelligence, but I also think consciousness is embodied. And so I'm not very bullish on the idea of mind uploading.
It's going to happen.
I mean, this is the argument. My last lunch, I'm going to be arguing about this.
I guess the problem is you have like different definitions of what is consciousness, right? Because what Michael's saying is that you can't have a consciousness without it being tied to a physical body, because the inputs and the relationship between the body and how it interacts with the world define the consciousness. Whereas, but you're saying that it's not, you're going towards more the brain in the vat idea, that you can have a brain in a vat and then you can upload to that
But
brain.
you can, right, so you have.
That's two different definitions of consciousness.
Yes.
But
That's
so
what I'm
right
saying.
now, you have an artificial limb and you can still have feeling, right? Through Neuralink and a lot
Yeah.
of your brain implants that we have. Alright, so now you can replicate almost everything else in your body for those sensations. And we're saying today that a robot has, RAM, CPU, all that stuff today making processing, but maybe that's more bio in the future. We don't know. You know the technology we're working on.
So let me touch a little bit on that. The AI that we are creating is a very basic imitation of what's happening in biology. Like in my PhD, I was working in a small neural network in the stomach of crab. So this stomach has like 6 neurons, just 6 neurons. But the way that these neurons are interacting with each other, the electrical characters of them, it's not 0 and 1 like the way that we do like in AI, like 7 neurons that have 0 and 1. So it has a lot of complexities that we haven't input them in the AI code. The AI world now is a very bird's eye view imitation of the biology. We are trying to do that. Like, let's say, for example, facial recognition algorithm, right? The way that we do visual perception in our brain to recognize faces is completely different than facial matching or facial recognition that is done in the AI side. So we are trying to build that, but it's far from each other.
Right, but it's also like in the 70s and 80s when we said that we had AI, we did, right? You know, where are we today? We're just now, you know, putting it into practical application. We have the forever future to work on these problems. So this is future problems that we'll have that we'll end up solving. And so we'll try to emulate us, no? We always try to emulate us, or emulate the future.
Yes, what I'm trying to say is that fundamentally it's different because 0 and 1 is not happening in our biology. Like the axon, dendrite, the way that the biology works is not 0 and 1. It's much more complicated than that.
Can I add, that's exactly the point about complexity science and complexity adaptive systems. Quantity then becomes qualitative differences. So you can't just, we're not just, even though we're mimicking biological, or trying to mimic biological systems, it becomes qualitatively different. You get emergent properties, which consciousness might be, and embodied properties. And that's why I think, like, that's the point I was trying to also do.
So if we can
it's
grow
qualitatively distinct.
But if we can grow a ear on a rat, and we're gonna grow brains in labs, so we aren't gonna be able to put our stuff into brains, or we're not gonna be able to go bidirectionally information from external to internal, because right now we can take the internal and read on the external.
So,
If I can just,
Yeah.
one more. You're assuming that we can perfectly translate the brain as we have it today. I'm saying you can't because it's qualitatively different to ones and zeros, right? And the process of fabricating a body that could then take the download, I think, is on a time scale that is completely off with the time scale of the evolution of AI. So the AI and ASI will happen much quicker, because talking about AGI doesn't really make that much sense, because it's like a short stop on a freight train that's going full speed.
But we're gonna get there.
But it's gonna be there, and then it's gonna be gone the next day. We're going to ASI, so I think that we're not gonna get to build what you're talking before the ASI is here.
ASI might be the one that builds it,
Possible.
right? Because ASI should be able to make new.
But why would you want to?
Who knows? I mean, that's just speculation.
Yeah, that's right.
yes, so this can be a long conversation, an exciting one. I like that. But
We're gonna let you step into
Another thing I was gonna say about
what?
it's a little different than what we were saying before about that we have different consciousness than like a cat, for example. But a cat still knows that it's a cat. It's conscious. We may have paws, have hands, and they have paws, but they still feel with their paws just like we feel with their hands.
Yes.
We may have different vision, but we still see.
Yes.
So it's different, but we're still conscious.
Absolutely.
Just because we act differently than any feline doesn't make us two entirely separate forces of nature or whatever, like two entities. You know, we're different, but we're still conscious, and that's the most important thing
Yes.
in AI, because it's artificial intelligence. Cats aren't artificial intelligence.
Yes.
No, it's all the same.
We're closer to cat than to this thing.
No, we are, and that's what separates us. But a cat would still be conscious. If I got a cat and I put it right here, it's not going to understand a word we're saying, but it still knows it's here, it still knows that we're talking.
I would trust the cat more than the entity.
Sure. So exactly, the cat is conscious. In fact, any being with a central nervous system, or even the ones that don't have central nervous system, they are conscious. The way their consciousness is different, we cannot perceive that, because let's say if we only see like this spectrum of light, right? So we cannot describe what's happening in this side of the spectrum,
Right.
because we don't have any understanding of that. This is the same way. We cannot understand their consciousness. We can just guess how it would look like, or we cannot guess. Like the game of Go, right? It made a move that we, as humans, we were like, okay, this is a non-human move. We cannot do that, right? This is the same way. So they are conscious, but different than our consciousness. And the AI would be conscious at some point, but not the way that we are conscious.
Right, in a different way. Right.
So back to that conversation. So we would have virtually a being. It has legal rights. It's a company. It's a large company. It controls money and everything, and we are working for that. Until it needs us. Maybe at some point it doesn't need us, right? That's a big question. Maybe we are consuming too much of the oxygen in the world, or we are just a parasite for that being, and it wouldn't need us, right? So that's not a beautiful picture. If we give AI any legal rights, I call it the Matrix scenario because it's kind of like reminds you like the Matrix.
But do we need to get to the point where we give it legal rights, and then, or should we just align incentives and rewards with what we want?
Where do you draw the line though? Like, how intelligent does it have to be to have legal rights?
Sorry.
Like, how advanced does it have to be to gain legal rights? Like,
Yeah.
how do